Hi, my name is Run Han. I'm a PhD student from UC Berkeley. Today, I'm going to talk about our SIGMETRICS paper on dispatching. This is joint work with Isaac Rosoff and Zeev Scully. The problem we're interested in is the following. Imagine we have two identical first-come, first-served servers, each keeping its own queue and serving jobs at rate a half. A stream of jobs arrive at the system according to a Poisson process, and the size of each job is taken from some probability distribution. When a job arrives, a central dispatcher has to make the decision as to which queue the job gets sent to. Specifically, we're interested in designing a good dispatching policy so that we're able to minimize the mean response time. The response time of a job is the time between when a job first arrives and when it completes service and leaves the system. Dispatching is a very classic problem in queuing theory and has been extensively studied. The scenario we're interested in has the following assumptions. We assume that the dispatcher knows the job size and distribution, hence the size-aware part, and it also knows the system state, work at each server, hence the state-aware part. Surprisingly, this particular scenario where the dispatcher knows everything about the system is an open problem, as pointed out by Hutia et al. Figuring out an optimal policy for this under any arbitrary load is a very difficult problem. Therefore, in this particular paper, we focus on the heavy traffic regime, which is where the load of the system approaches the total processing capacity. Since dispatching is such a classic problem, it has been extensively studied and different ideas have been proposed and explored. The first idea is to optimize the delay for each arrival. The policy that uses this is called least work left. Roughly speaking, least work left is going to dispatch a job to the queue with the least amount of work. In heavy traffic, it can be shown that the mean response time under least work left is roughly the same as the mean response time under resource-pooled MG1, where there's a single first-come, first-server processing at rate 1 and a single queue holding all jobs. A question we ask is, can we do better than this? The second idea is to create an express lane for small jobs. The policy that uses this idea is called size interval task assignment, also known as SITA. What SITA does is that it's going to divide the jobs by their sizes into small and large jobs, where small jobs and large jobs each contributes to half of the load. It pre-assigns one of the server to process only the small jobs, and another server to process only large jobs. When a job arrives, it's going to get dispatched to the pre-assigned server. A natural question to ask at this point is which one of these two ideas is better? Surprisingly, neither SITA nor LWL consistently outperforms each other in terms of mean response time, as pointed out by a paper in 2009. And why is this the case? This is because they have their own pros and cons. Least work left actively controls work amount in each queue, but it does not separate small and large jobs, so small jobs can get stuck behind really large jobs. And SITA, on the other hand, does just the opposite. The policy we proposed in our paper, CARD, is able to achieve both. Specifically, the dispatcher is going to dispatch all small jobs to one of the servers and all large jobs to another server. So CARD is able to separate small and large jobs. But CARD also has a third class of jobs, which we call medium jobs, with size around n. These sort of jobs can get dispatched to either queue depending on the specific state of the system. And CARD is able to actively control the work amount in each queue using these medium jobs. The key theorem in our paper is to prove heavy traffic optimality under CARD. If you're interested in the detail of our work, please read our paper, where we describe the details of how CARD works, including an n-server version, where n can be any number greater than or equal to 2. The key theorems and proofs, including a new lower bound on the mean response time for any dispatching policy. This is one of the key steps in proving heavy traffic optimality of CARD. We also have simulations that show that CARD performs very well even outside the heavy traffic regime. Thank you very much for your attention.